So one of the applications that you can use for trig is you can use it to find the arc length and area of sectors, okay, which is an important little thing just to be able to find sometimes when you're calculating different things. So we're going to take a look at that and how we're going to calculate that. So first off, just some definitions of what we're talking about. Okay, so this circle right here, you see how we got this angle here that comes in to the center of the circle? Okay, that angle right there, that is called a central angle. Okay, so it's called a central angle because it comes into the center of the circle. All right, this right here, okay, which if you kind of think about it like a pizza, that's like the crust on your slice of pizza. Okay, that is called the intercepting arc. Okay, so the intercepting arc, it's the arc that intercepts this central angle. So you have a central angle, and where that central angle encompasses the edge of your circle, that's called an intercepting arc. All right, and again, with my pizza analogy, if you think about this section here, it's like the slice of the pizza, so the whole little thing, okay, that is called the sector of a circle. Okay, so that's called a sector, and that's like the whole slice of pizza. Okay, so we've got these three things, and what we're going to do is we are going to use some of what we've learned to find the length of a intercepting arc and the area of a sector. So essentially, how much crust do you get on your piece of pizza and how much pizza do you get total? Okay, so this guy right here, this is the formula for arc length. Okay, so formula for arc length, some key things that you should know. Okay, S stands for the actual arc length. Okay, R stands for the radius of your circle. All right, and then here's the key one, that angle. Okay, so theta stands for the angle. All right, so that's your central angle. Okay, but here's the tricky part. It has to be in radians. Okay, you can't use that in degrees. This formula will not work if you try to calculate it using degrees. It has to be in radians. Okay, so it's a really simple formula. You figure out your radians measure of your central angle, multiply it by the radius of your circle, there's your arc length, done. Okay? All right, now for the area of a sector, okay, it's gonna be along similar notes. So area of the sector, A stands for your area. Oh, I don't know why we'll make that an exclamation mark because I put like a random extra line after the end of the word area. That stands for area. Okay, R is again your radius. Okay, and then again, theta, that is your central angle, just like it was in the last one. But again, it has to be in radians. Okay, that's really important. So you have to make sure it's in radians. You can't use degrees. Okay, so you can't use 90 degrees. You have to use pi over 2. All right, but other than that, these formulas are really, really easy. Okay, so let's take a look at this one. The school's doing repairs to their softball field. They want to replace the outfield fence and also cover the fence in new sod. So how much fencing and how much sod should they order? Okay, so here's our lovely photo of our outfield. So you notice that this is a 90-degree angle here. This is 200 feet going in both directions. Okay, so we're going to use that to figure out the answer to these two problems. So I need to calculate the arc length. Okay, because the arc length would be the field, right? Or I'm sorry, not the field, the fence. Okay, so the fence that covers this area here would be the arc length. Okay, and then to cover the whole thing in sod, that would be covering this whole area, right? Well, then we need to know the area of your sector. Okay, so we're gonna need these two formulas up here. And I know that my angle here is 90 degrees, but as we've established, you need to know your angle in radians in order to convert, in order to solve these problems. So the first thing that I'm going to do is I'm going to convert my 90 degrees to radians. Okay, so we're going to convert 90 degrees to radians. So we talked about this yesterday. So I got my 90 degrees and I'm going to multiply it by a fraction. And I want degrees to cancel, so I'm going to put the 180 degrees on the bottom, and I'll put pi on the top. And I'll just stick a 1 under my 90, so it's a nice fraction. All right, I'm going to multiply straight across, so that's going to give me 90 pi over 180. and then simplify that like a fraction. That's going to simplify to 1 pi over 2. That's right, 90 and 180 simplify to a half. You can put the 1 at the top if you want to, but you don't have to. All right, great. So now that we have that, now we can go through and find our 2 different answers. So for our fence, I'm going to need the arc length, right? So that'll be my arc length. So my formula says that to find the arc length S, I need to multiply my central angle measured in radians. Well, that's pi over 2. And I'm multiplying that by r, the radius of the circle. That's what this is, right? Here's my whole big circle, right? My whole circle would come this way. Okay, this is the radius of my circle. So my radius of my circle is 200. Okay, so pi over 2 times 200 over 1, that's 200 over 2. That's going to simplify to 100 pi. Okay, and then in this instance, it makes more sense for us to write our answer in terms of a decimal, because like if somebody asked you like, oh, how many feet of fencing? You wouldn't say like 100 pi feet of fencing. That's weird, right? So I'm just going to calculate that really quick on my calculator. 314.2. So that's about 314.2 feet of fencing that we would need. Now, obviously, if you're actually doing this problem or this project, you'd want to round that up, right? So that you have extra fence. You always want to make sure you have extra fence, not too little. So just in case something goes wrong, order more. All right. And then the second thing that we want is the sod. Okay. And the sod, that's going to be the area of my sector. So that is this formula up here. So my area is 1/2 times the radius squared, that's my 200 again, and then times that same central angle in radians. We already calculated that, so that's pi over 2. Okay, so I'm going to go ahead and simplify that. So 200 squared, you can probably calculate that one in your head, but that's a really big number. All right, and then we're taking half of that, so I'm multiplying it by 1/2. Okay, and then I know I'm going to divide it by 2 from this guy, right? So if I divide that by 2, that's going to work out to 10,000 pi. Okay, and again, I'm going to express that answer as a decimal because that just makes sense in this situation. Those would be square feet. Okay, now you're thinking to yourself, but Miss King, that's not how outfields work, right? There's like sand and stuff on there that, yeah, well, we're just going to overlook that, okay? So we're just going to go with figuring out if we covered the entire area in sod, and we'll call the sandy parts your extra, okay? All right, so arc length and area, really simple. Make sure you memorize those formulas because you're going to need to know them, okay? And you just really, really have to remember that you have to always convert to radians. So make sure your measure is always in radians. If it's already in radians, you're good, you're set, okay? But if it's not, you're going to have to convert it.